Hi, my name is Safarut, and I would like to present this research titled Web-ALAP, a web-based LaTeX editor for blind individuals. I worked in collaboration with Shaban Zulfikar, Qasim Hunain, Dr. Sulaiman Shahid, and Dr. Asim Kareem at Lahore University of Management Sciences. Our major motivation behind this study was to create equal opportunities for everybody and utilize the ubiquitous nature of web resources. When we evaluated existing technologies, we realized that although web is universally present, but there is a lack of web-based technologies that support creation of mathematical content. Most of the accessibility solutions do not have a fully integrated text-to-speech engine, which leads to external dependencies and unexpected behavior. And desktop systems require tedious setups, and chances of misconfiguring them are always there. Before we talk about Web-ALAP, let's talk about LaTeX editor. So LaTeX is a widely used system for high-quality scientific document preparation. LaTeX source files are usually converted to PDF for presentation, and visually impaired users can use the online LaTeX editors such as Overleaf by pairing them with screen readers like JAWS and NVDA. The screen readers perform reasonably well while working with continuous text. However, they provide insufficient support for mathematical content and dynamic tasks like compiling and debugging a document. Our goal was to design a web-based system that enables blind users to author and present LaTeX-based documents without requiring any external interference. Therefore, we developed Web-ALAP, which is an open-source, platform-independent, web-based LaTeX editor equipped with accessible debugging features and fully integrated text-to-speech engine that supports correct descriptive narration of mathematical content. Web-ALAP requires a zero configuration and no pre-installation at all. It also assists users in debugging by offering comprehensive feedback upon document compilation. It provides accessibility of the editor, and it makes advanced math accessible through a feature called Math Mode. Before we can debug LaTeX, we have to write LaTeX, and Web-ALAP makes editing accessible through consistent speech feedback and supports a set of shortcut keys to help users navigate inside the editor. It also informs the user about the status of the document and whether it got compiled successfully or if there were any errors. Let's see how Web-ALAP helps users in editing and debugging through this pre-recorded demo. So I've opened up the web portal. The UI is pretty simple. It is a split screen with LaTeX editor on the left side and compiled PDF on the right side. We can compile the document using Shift+S key.
LaTeX file is compiled.
After compilation, as you heard, we get comprehensive feedback that document got compiled successfully. Now let's try writing a basic mathematical equation. I'm going to write a simple fraction equation, 1/2.
C 1 2 \frac start curly bracket 1 end curly bracket start curly bracket 2 end curly bracket.
As you heard, the TDS engine narrates the characters as I type them out, and upon pressing space, it narrates the complete word. I can also listen to the contents of the line using Shift+S, L, but before that, let's try and compile the document again.
Found errors in LaTeX file. Misspelled on line #15 LaTeX tag frac start curly bracket 1 end curly bracket start curly bracket 2 end curly bracket.
As you heard, that Web-ALAP just informed me that there is an error on line number 15. To confirm what line I am currently on, I can use the shortcut key Shift+G.
15.
We'll listen to the complete line once again using Shift+L.
\frac start curly bracket 1 end curly bracket start curly bracket 2 end curly bracket.
Now I'm going to fix the error by surrounding my equation with $sign.
Home.
Let's compile the document again.
LaTeX file is compiled.
As there were no errors in LaTeX code, I got a message stating that LaTeX file is compiled. The next feature of Web-ALAP that I would like to talk about is Math Mode. Math Mode supports correct narration of mathematical content, and it can be activated through a shortcut key Shift+Z. Web-ALAP appends appropriate keywords to indicate the start of corrections, subscripts, superscripts, roots, summations, and so on. And it also supports an extensive set of basic and advanced LaTeX math commands. Let's see a demo of math mode as well. So I've already written a bunch of equations onto the LaTeX editor. The equations are a combination of fractions, summations, roots, limits, sub, and superscripts. Let's see how Web-ALAP narrates these equations in math mode. The shortcut key for that is Shift plus Z.
Summation underscore n is equal to 1. N sub. Raised to power infinity. End power. 2 raised to power minus n. End power. Is equal to 1 f open parenthesis x close parenthesis is equal to integral raised to power a. End power. Underscore b. N sub. Fraction numerator 1. Over denominator 3. End frac. X raised to power 3. End power. Limit underscore x to infinity. N sub. F open parenthesis x close parenthesis integral ellipses integral underscore v. N sub. Cube root inside radical. X. End radical.
We evaluated Web-ALAP with 10 visually impaired students. For comparison, we used Overleaf paired with JAWS. Participants had to perform a total of 5 tasks with both systems, and we recorded the performances and later analyzed them to deduce results. We used various metrics to measure the performance of both systems. One such metric was error recovery rate, which was the total number of errors fixed by a user within the constrained time limit. Average error recovery rate for Overleaf was 1.0. However, average error recovery rate for Overlap was 3.8. Like all mainstream editors, we hope to extend Web-ALAP and equip it with features such as collaborative editing, ability to share documents, and a comprehensive template directory. The key contributions of Web-ALAP is that it is a fully integrated text-to-speech engine that understands LaTeX and offers a comprehensive narration of LaTeX-based documents. It is also equipped with features like accessible debugging and assistive editing, and it is open source, platform independent, which can be accessed globally through a URL. I'd like to conclude with a quote of Tim Berners-Lee that the power of web is in its universality. Access by everyone regardless of disability is an essential aspect. Thank you so much for watching this presentation. If you guys have any questions, please feel free to reach out to me, or you can visit our website. Thank you.